G'day, welcome to Exploring AI. In this episode, I'll show what happened when I asked GPT-4 to design and code a game for Android devices. I started with several questions in mind about the capabilities of GPT. Could it design a game with realistic rules? Could it design the graphical components necessary for the game? And was it capable of writing the code necessary for the game with little to none of it written by me? If you've coded for Android or used any modern high-level programming language, you'll know that the best way to create something is to split it into parts. In Android, using Java or Kotlin, that means creating various classes and placing them in appropriate packages. I performed some experiments with this concept using GPT-4 and found it was suboptimal for the task of writing software from scratch. If code is placed in different files, then it is necessary to give GPT a zip file with the complete code for it to continue to add code. When GPT has a large context window, I found that it sometimes got quite confused when it had to work with separate files over several iterations of coding. Sometimes it wouldn't even examine all of the files, even though that was required in order to add the next piece of functionality. The added disadvantage of using multiple files is that the entire code tree has to be zipped and uploaded to GPT on a regular basis, a lengthy and annoying procedure when you want a fast back and forth between GPT and the human overseer. For the task of coding a game, I decided on a superior strategy, placing the code in one file. As sections were completed and not needed for additional functionality, I broke them out and placed them in separate files. This just left the core code that GPT was currently working with. This strategy not only allowed GPT to only see what was necessary to use, but it meant I could easily copy and paste the code directly into GPT's prompt window, allowing for fast and efficient iterations. Once I'd decided on the strategy, I chose to use Kotlin as the programming language and Jetpack Compose for any user interface elements that might be needed. From this point, I wanted GPT-4 to create everything else with minimal intervention from me. I next asked GPT-4 to think up a computer game. It suggested a board game with pieces that could move and/or fire projectiles. Unfortunately, and with such bad timing, our conversation ended due to network errors, and I had to wait a few hours before starting a new conversation and priming GPT with what it had previously decided on. Given the broad outline, I asked it to give me a set of rules and also give me a name for the game. GPT suggested the name Stratagem of Valors, a rather odd name. Who was I to argue? The rules were fairly straightforward and it seemed to be quite workable. The next step was to get GPT-4 to design some game icons. I gave it the list of rules and asked for some icons. At first, GPT-4 wanted to use DALL-E 3 for making the icons. As I soon realised, there was no clear consistency across the icons and they were mostly three-dimensional or with too many details for displaying on a board. I asked GPT-4 to use its Python programming capabilities to generate simple geometrical icons. Once I had the set, there was some more negotiation on the details of the icons. As is so typical with working with this AI, it will correct one mistake and then introduce or reintroduce another. Eventually, we arrived at a set of icons I was pleased with. I took these away and coloured them appropriately for the two sets. I could have asked GPT to do this, but it's a simple task and I just didn't need the headache of it possibly reintroducing errors into the designs just to change the colour. With the icon designs done, I now needed to know where the pieces would go on the board. I asked GPT to draw me a diagram of the board and how it would be initially set up, something that was not detailed in the rules. GPT drew the board, although it took a couple of attempts to get it to provide a meaningful color key so I could see which of the 5 types of pieces went where. One interesting thing is that there is a gap of 2 rows in the setup for both sides and also a gap in front of each flagship piece. I have no idea why it decided to do that, but it doesn't seem to affect gameplay. I attached numerical positions of the initial board setup to the end of the description of the pieces in the rules document. Now that I had a set of rules, the icons and a board layout, it was time to get GPT-4 to write some code. I gave it the rules again and asked it to create a skeleton Android project. In actual fact, I created an empty project and then incorporated the code in the files it produced into my project, as I didn't have much faith in it producing a complete Android Studio project by itself. Amazingly, the drawing of the 8x8 board worked perfectly first time, although there were some gaps between the squares which we had to deal with. With the information about how the board piece icons were named, I got GPT to display the icons on the board in the starting positions as given in the rules. I also asked it how it intended to show how the pieces were selected for moving and what squares were valid to move to. I then proceeded in getting it to display the firing ranges of the projectile pieces. Again, a lot of to and froing in getting it to incorporate the necessary code, although this was relatively painless, as it was just an extension of the valid move routines. Finally, we had a 2-player game. In the second part of this episode, I'll cover the game logistics and the added complexity of a computer AI opponent. You can find the code for this game on GitHub at the address shown on the screen and in the episode description below.